Hello. So we have studied about that the direction of the force applied is the direction of the acceleration. So no matter what, if we increase the uh, suppose there is a vehicle, and in vehicle, you know, there are two things. Suppose this is a bus and there is a driver here. Okay, so the driver increase the there are two things. One is the accelerometer A, represented by A, and one is the brake. Okay, so if you the both of these things are actually used to provide the necessary force, but in particular direction. Okay, we will see. So whenever you press the accelerometer, so it will speed up in the direction of force applied. So the direction of the force is in the direction of the motion of the vehicle. So accelerometer increase the speed. Okay, now when you apply the brake in a vehicle, the direction of the force is actually in the direction of the reverse of the direction of the motion of the vehicle. So the force applied in negative direction, or it will provide negative kind of acceleration, so it will decrease the speed. So whenever there is a acceleration opposite to the direction of the motion, it will decrease the speed. Okay, the third change in the direction is due to the change in the path. Okay, we will see it in next session. So the direction of the displacement, I have told you earlier that the direction of the displacement tells us which side the object is, the direction of the velocity tells us which side the object is going, the direction of the acceleration tells us which side the object is experiencing the force. Okay, so it is the always to the direction of the acceleration is always towards the applied force. This is the important definition. The direction of the acceleration is always towards the direction of the applied force. Now we will see how, representing by taking the example of different cases. First case here, we will see about, we will talk about the distance. Okay, okay, so suppose you are standing here, and from your axis, from your vision axis, there are two directions, one is upward and one is downward. Okay, here upward and downward. So you will take the downward axis as negative and upward axis as positive, like positive y-axis, because this is origin, this here is your eye, this is origin, and the upward axis is positive y, or downward axis is negative y. So from here you can see that when you throw a ball, it will travel from 0. Okay, for let's say it's a 45-meter height, so it go till the 45-meter height by covering 0, 25, 40-meter distance. This is distance. Okay, 45-meter distance, and after covering the 45-meter distance to its maximum height, it will come back. When it will retrace its path, it will further add its distance. So the distance is the total covered path covered by the body. Okay, so the total distance will be addition of all these distances covered. Okay, now we will go to the displacement part. Same axis, if represented, if when represented, you know that displacement is a vector quantity. So the positive direction, whenever it is in the positive direction, it will take the positive route, that is plus 25, plus 40, plus 45, and after going till plus 45, it will again retrace its path till it came to its original axis from where it has started. After that, the negative axis has been started, so the negative axis will be retraced by -1, -2, -3 till -25 here, and till -50. So when it traces its path, since it is a vector quantity, you see when it had gone from here to here and then back here, the total displacement became 0. So because it is a vector quantity, it is represented by a direction. Okay, so from here to here the total distance was 90, but the total displacement, because it retraced back its own path, so it became 0. And again when it went further down, it will not add up, it will just become negative. After this point it will become negative, and the direction is reversed. Okay, reversed from the original axis. So whenever we talk about distance and displacement, we always take the axis into consideration. That is the reference frame, reference point. Okay, that is important to note. Okay, next we will see about the speed. So you know, speed is a scalar quantity. So when we are going to talk about the speed, first when you throw a body upward, obviously you have given it a greater speed. Suppose 30 meters per second, it is represented in meters per second or kilometer per hour. Okay, depending on the SI unit. So you have thrown with a certain speed, let's say it's 30, it will decrease. When you throw a body upward, the speed decreases. Okay, why? We will see. Then it will become 20, then it will become 10, and finally at the topmost point the speed is 0. Okay, again after reaching to the topmost point, it will retrace its path and it will again increase its speed. Similar way it has been decreasing, same way it will increase the speed. It will become 10, it will become 20, then at the same point from the reference where it has started, we are always talking about the reference point, it will become 30, and after it became 30 meters per second, further if you catch it, then it will come back with the speed of 30 meters per second. If you talk in the terms of kinetic energy, it will become half of m mass of the ball, and that speed v square. Okay, we always take speed in terms of kinetic energy. Okay, that is why we always take, this is the speed, not velocity. Okay, okay, okay. So it will came back with the same energy the way you have thrown. But if it go further downward, it will again going to increase its speed. Okay, okay. So it will further increase its speed and further it will go down. Okay, now it has a definite calculation. You have to calculate its value, depend on the how much distance it is going, the value will be at with a definite speed, you will get that value. Okay, now with the velocity, now velocity is a vector quantity. So with the vector quantity, you know what will happen, you have given some speed in a particular direction. So same way the direction has been taken upward, positive, but till upward it has velocity, it will decrease in the value, 20, 30, but it will be the one particular direction up to the topmost point. After getting the topmost point, it will increase in value as it come downward, but it has changed its direction, that is downward. So it will become negative here. So here the partition is like this, here all positive, and after it has reached to the topmost point, everything will become negative. Okay, okay. So at the topmost point it is changing its direction, so it will become negative. So positive and negative in velocity case only shows the direction, not the magnitude. The magnitude here is decreasing, here the magnitude is decreasing, and here it is increasing, but the direction is this way and here the direction is this way. Okay, we have considered about the velocity. Now we will see about the acceleration. What about acceleration? So the acceleration while studying acceleration, you have to consider okay at every point after it has lost its contact with your hand, every point the acceleration, the force at which the earth is attracting the body is downward. So at every point, actually it is 9.8 meters per second square. So at every point it is 9.8 meters per second square. Is the value of the acceleration. So no matter at which height it has reached, if you are on earth, suppose you are on earth, the acceleration will always be at every point 9.8 meters per second square downwards. Here also downward, here also downward, here also downward, here also downward, because the force of by which the earth attract the body is always at downward direction. So the total acceleration will at every point is to sum up is minus 10, you can take for easy calculation, meters per second square. I hope this is clear. Okay, if we go to the next, distance is the value on the odometer while speed is the value on the speedometer. So odometer give the distance. So you have odometer in your vehicle that always gave you the distance covered. Okay, not the speed, not the direction, but only the distance. Okay, the thing that always move on like this, that is odometer. And the value of speed is given by speedometer, not the velocity. It do not give the direction in which direction you are traveling. The speedometer only give you the magnitude. And odometer only give you the magnitude. So these both are represented by odometer and speedometer. If the question comes, what odometer shows, that will be distance covered. Okay, we will see about the cases about the angle in next class. Okay, thank you.